Okay, lesson 4.2. Here we are. We are going to learn how to write equations in point slope form. We'll write an equation of a line given its slope and a point on the line. And this time the point will not have to be the y-intercept. We will also be able to write the equation of a line given 2 points. Then, of course, we'll try our hand in solving a real life situation or word problem. So here we go. Here is our point slope form. This is the key idea, core concept, and this is in your student journal, I believe on page, sorry about that, 103. So all of this is on 103. And here's the form. Y minus y1 is equal to m times the quantity x minus x1. So we call this the point slope form because we see the slope is m, and here is a point that it passes through. So this first y and this x are going to be part of the equation, and if we solved for y, we would then have it in slope-intercept form. So any 2 points that you have on the line right here, okay, here's where we get our x1, y1, right? We just name one of the points. So let's give it a try. All right, so we'll use a slope and a point to write the equation of a line. So we want to write the equation in point slope form. If the line passes through the point -8, 3 and has a slope of 1/4. So we will substitute in the values. This will become x1 and this will become y1. And then of course this is m. So here's your point slope form. You put in your 3. Since it's obviously a positive 3, it stays as y minus 3. When we substitute in a -8 for x1, notice that we have minus a -8, and we can simplify that to +8. So if we simplify, we have this, okay? So for these first few examples that we're going to do, we will actually be writing it in point slope form. We will leave it in point slope form. So let's try this out. So on page 104, you will see these examples, and we'll do 1, 2, and 3. And we'll take the point that they give us and the slope, and we will write the equation in point slope form. So remember, we're going to substitute this in for x1. This will be y1. So this is our point, and this is our slope. So our point slope form looks like this. Okay, so let's just substitute in y minus 1 will be equal to a -3 times the quantity, x minus this -2. So we can simplify to get y minus 1 is equal to -3 times x plus 2. And we are done. Okay? No need to take it into slope-intercept form because it says to write the equation in point slope form. Okay, next up, y minus 5 is going to be equal to your slope times the quantity, x minus 3. Do we have anything to simplify? No double negatives? Nope, we are good. Here's our point slope form. Again, we substitute this in for x1 and this in for y1. Okay, next, y minus the -2 will be equal to -1 times x minus -1. So we can simplify the double negatives. Y plus 2 is equal to -1 and then x plus 1. Close parentheses, and we have our answer. Okay, moving right along. So to write an equation of a line given 2 points, When you're given 2 points on a line, you can write an equation of a line using the following steps. 1, we need to find the slope of the line. And if we have 2 points on the line, we can calculate it using the slope formula. Remember that we will take y2 minus y1, which will give us the change in the y coordinate, and put that over x2 minus x1, and that's the change in the x coordinate. Then we'll use our slope and one of the points, and it really won't matter which one of the points we use to do this. Typically, since the formula says like use, y1 and x1, I like to pick the first point that comes in order. Here we go. So we're going to use 2 points. So here's our 2 points, 1, 2, and 3, -2. Calculating the slope, right? Change in y over change in x, and then use the slope and one of the points, and they just happen to pick this point. So we'll substitute that in. Now, when we get down to this step right here, because it wants the line in slope-intercept form, we go ahead and solve for y. So first step, distribute the slope. Then we're going to, add 2 to both sides so that we can isolate the variable y, and we're left with y is equal to negative 2x plus 4. So we will actually be giving this a try. All right. Calculate slope between 2 points. Here we go. So 2 minus negative 2 all over 3 minus 1. So 4 over 2, I'm calculating a slope of 2. So I have a slope, and I'll take one of the points, and it won't matter which one. I'll go ahead and take this one. So y minus 2 would be equal to 2 times the quantity x minus 3. Distribute through multiplication, 2x minus 6, and then add 2 to both sides, and we'll get y is equal to 2x minus 4. And note that that -4 is where it's crossing the y-axis, and we can see very clearly that it is. So if you want to pause the video and give this a try, I'm going to continue. So I'll calculate the slope. So we have a slope of -1. So y minus, and I'm going to use this point. Again, you can use either point. So if you want to try it out using the other one, we should get the same answer in slope-intercept form. The point-slope form might look a little different, but the slope-intercept form would always simplify to the same. So y minus y1 is equal to our slope times x minus x1, which is 1. We'll distribute. So negative x plus 1. We will add 2 to both sides, and we'll get y is equal to negative x plus 3. And pretty easy to check that it is crossing y at the positive 3. Okay, again, you can go ahead and pause the video. We'll calculate slope. I get a slope of 1/2. It's a positive 1/2. So if I substitute in, I'll use this point. Okay, now I'm doing y minus, and remember this is a -1, is equal to my slope, and then x minus 2. I need to simplify here, so I'll have y plus 1. I'll distribute. So I'll have 1/2 x, and then -2 times 1/2 will be a -1. Then I will subtract 1. So I'll get y is equal to 1/2 x minus 2. And again, I want to double check, am I crossing the y-axis at -2? Yes, I am. And I have a slope of a positive 1/2. Okay, again, if you have any questions, make sure to write those down. Writing a linear function. So the main thing that we'll have to be able to do is write an ordered pair, right? We have to know that this is the input, this is the output. Input, output, okay? So we represents the points 4, -2, and 8, 4. Same process. We can go ahead and evaluate. We can, oh, these lights always pop off on us. Okay, here we go. You can simplify, you can get a decimal, you can get a fraction, however you want to work with it, because you're going to be distributing, right? And then you're going to be solving. Now, at the very last step, after we get our slope-intercept form, we just want to substitute in this function notation. There we go. 13, 14, and 15. Start by writing the ordered pairs. Input is -3, the output is -1. Input -2, output is 4. So 4 minus the -1 over -2 minus the -3. So we'll get a positive 5. And here we'll get a positive 1. So our slope is equal to 5. Take any one of the points. I'll take the first one. So y minus this -1 is equal to 5 times x minus this -3. So that's the main thing, is to keep it from the same ordered pair, -3, -1, -3, -1. So simplify, y plus 1 is equal to, we have 5x plus 3, and then we'll distribute. We'll subtract 1, subtract 1. Once you get this written, you will then write f of x instead of y. Another little, just practicing that function notation. And the reason we use function notation is so that we can work with many different functions at a time. Okay. So again, pause the video and try to work this out, and then you can check your work. Make sure you get your ordered pairs, input, output. Calculate your slope. All right, 6 over 3. So we'll have a slope of 2. I'll just take the first point, y minus 1 is equal to 2 times the quantity, x, and I'm going to go ahead and simplify right here, right? Instead of doing the double negative, I know that I have to simplify. So y minus 1 is equal to 2x plus 4, add 1, add 1, y is equal to 2x plus 5, and then substitute in the function notation. Okay, here we go. And moving right along, -1, 2, and the input of 3, the output of 3. So calculate slope, change in y over the change in x. We have positive 1/4. I'll use the first point. So y minus 2 is equal to a 1/4 x plus 1. Again, I just dealt with the double negative, right? Minus a negative is plus 1. So I'll distribute. Y minus 2 is equal to 1/4 fourth of x plus 1/4. I'll add 2 to both sides. So y is equal to, now in doing this, when I have this, I guess I can put it as, maybe a decimal, 2.25. I'm going to go ahead and keep it as an improper fraction, right? So we would have 9/4. So our function notation would be 1/4 of x plus the 9/4, because I can't simplify other than to change it to a decimal. You probably don't want to do a mixed number. Okay, and so let's keep things to improper or decimals. All right, so when we're modeling with mathematics, so this case, we have a student ordering customized foam hands to promote the school spirit. The table shows the cost of ordering the different numbers of foam hands, and we want to know, can it be modeled by a linear equation? And explain. If possible, write the linear model that represents the cost. So, we weren't necessarily able to do that in the last unit that we studied. We could tell if it was linear or nonlinear, but we kind of stayed away from writing the linear functions unless we had an input value of 0 so that we knew what the y-intercept was. Now, using the point slope form, we can calculate it. So when we look at this, it says find the rate of change in consecutive. So between, the difference, y2 minus y1 over x2 minus x1, we get a 6. The change here, 6, 6, 6. So let's see. It's kind of like the way it's changing, right? Here is going from 34 to 46 is 12, right? Plus 12. I guess I should write the plus 12. How is this changing? This is going up by 2, up by 2, up by 2, up by 2. So everywhere, right? 12, the change in y over the change in x, everywhere between all of these is equal to 6, which they've modeled here. So since we have a constant rate of change, it is linear. Because it is linear, we can now write the function. So we'll use the constant rate as our slope, and you can pick any data pair to do this. They picked 4, 34, because remember, this is the x, the input value, this is the output, the y. So we have c minus 34 is equal to 6 times n minus 4, and then we'll simplify to get the function. So let's look at these tables. All right. So if we're going to look from here to here, right, we have plus 50. And then we have the difference. So negative 35 minus the negative 60 plus 25 plus 25 and plus 50. So, at first glance, you're going to say, oh, that's not a constant rate of change. But remember, we have to measure our slope or our rate of change as the change in y over the change in x. So from negative 3 to negative 1 is plus 2. From negative 1 to 0 is plus 1, plus 1, plus 2. So if you notice between the 2 points where you have your change in y over your change in x, we have 50 divided by 2. We have 25 divided by 1. We have 25 divided by 1. And we have 50 divided by 2. And 50 divided by 2 is 25. So the whole change in y over change in x is 25. The rate of change is 25 over 1. So yes, it is linear. So yes, it's a linear function. Okay, and since it's linear, well, we got off easy because the input value of 0 is right here. Okay, so we could write it as y is equal to 25x minus the 35, right? But we could also calculate it using the point slope formula if we need to, okay? Let's look over here. Going from negative 98 to 18, I have plus 116. Yeah, 116. From here, we have subtracting 10. And then here we have increasing by 54. Well, let's just take a look at how these are changing, right? So plus 2 plus 1. So these two ratios would have to be the same, and 116 divided by 2 does not equal a negative 10 divided by 1, okay? So this is nonlinear. And if it's nonlinear, we're not going to be expected to write the equation. So we want to be writing the equation in slope-intercept form. We can't do that, so we are done. All right. And finally, we have Craig. Here's our linear model here. He's driving at a constant speed of 60 miles per hour. So this word right here tells us this is our unit rate or our slope. So m is equal to 60. It says after driving 3 hours, his odometer reads 265 miles. So we want a linear function d that represents the miles driven after h hours. So we have kind of a sample here written of this. We have 265 is going to be equal to, we know that our slope is 60, and after 3 hours, but we don't know what our odometer read to begin with, right? We don't know the beginning value here. But in a way, yes, we have the slope, and this 3 hours right here represents the ordered pair 3, and the output value is 265, okay? So we can use the point slope form of the equation to calculate this, because we know that y minus the 265 is going to be equal to our slope of 60 and then x minus 3. So we can distribute. And then we will add the 265 to both sides. Which means we're taking the difference of this, and I believe the difference is 85. So y is equal to 60x plus 85. And in function notation, we know that we have d of h would be equal to 60h plus the 85, because the independent is the hours, and d, the function is d of h, would give us that value. Then it says, what does the odometer read after 7 hours? So now we could plug in a 7 here. So we could say, well, d of 7 would be equal to 60 times 7 plus the 85, and that would give us d of 7 would be equal to 505 miles. Okay, so there were two parts, writing the function and calculating how many miles you will have driven or what the odometer would read after driving 7 miles.